My name is Fahri Guniar. I'm director of the Summit content, and I'm first-year MBA student here at MIT. And in my first year being here, I'm proud to witness that we actually live by the motto "Mens et Manus," or mind and hand. And we think, we discuss, but we don't stop there. We act and we solve real problems in the real world. And today, we are proud to spotlight 3 startups that embody this spirit. Each one is tackling critical challenges in our food systems, housing, and the way we deliver goods and services, all with the goal of building greater climate resilience. They are each doing meaningful and impactful work, and we're excited to celebrate their efforts. But as with every pitch competition, only one will be selected as today's winner. And I'm going to announce who are the 3 startups that's presenting today. The first one will be Fluvic. The second one is Vedustruck. And the third one will be Infinite Cooling. And before we hear from their amazing pitches, I also want to introduce our judges for today. The first one, we're honored to have Jason Jay, who are the senior lecturer and director of the MIT Sloan Sustainability Initiative. And second one is Ivan Haas, who is the senior VC fellow at E14 Fund, and also the co-founder of Helix. Both MIT Sloan Sustainability Initiative and E14 Fund are sponsoring the prize for this startup pitch competition. And last but not least, the last judges will be you, all the summit audience. You'll be casting your vote as the third judge. And just a quick reminder on how to do that. We'll be doing the vote through the poll features in the Whova app. So you can go to the poll section in the Whova, and you can submit your choice there. And without further ado, let's get started. Woo-hoo! First up, please give a round of applause for Fluvic.
Hello, everyone. I grew up working on a vineyard as my parent, my grandparent. That was fun times, but I remember that the way we irrigated was just looking at the soil and guessing, okay, it's a good moment to irrigate, it's not a good moment. Right now, in US and Europe, more than 90% of the farms still do the same. They don't use any technological tool to optimize the irrigation. This is something that shouldn't be happening right now. And why is this happening? It's not a lack of technology tools. It's because current solutions are expensive with high upfront costs, complex to install and to use, and most importantly, they are untrusted, especially for small and medium farms with the technical capabilities. At Fluvic, we are building the climate intelligence layer for agriculture. And we are doing it focused on 2 main things: accessibility and trust. Because it's not about building more solutions, more sensors. It's about building solutions that farmers want and can use. Our value is very simple. We don't ignore or assume farmers are wrong. We incorporate their knowledge, their generational knowledge, into our solutions. We advise them, explain our decisions, and listen them. We do it in a very simple way. First, we get all the data we need. We use our self-developed soil sensors for real-time data, and we combine this with satellite imagery and with weather projections. This is nothing new, nothing disruptive. The important part is what happens now. We get all this data, and for the first weeks, we help farmers, and we understand them what they are doing, how and when and where they irrigate. With this, after the first weeks, we become their personal advisors. It doesn't matter if it's using a dashboard, it's using an LLM call, or some messages. We adapt the technology to their capabilities, and not the other way around. With this, we advise. One common question is, should we irrigate now, or should we wait? A simple and quick answer would be, we recommend irrigating. Why? Because the soil moisture is at 22%, there is no rain projected for next week, and the growth stage is this one. With this, we can help them understand their real needs, data-based. We offer this with a disruptive model that no one is doing in agriculture. Our costs are extremely low, and that allows us to offer a hardware as a service model. For just $20, $20 per acre per month, we can provide an end-to-end solution taking care of all the infrastructure. So anyone, regardless of the capabilities, can deploy the technology by themselves. We started a year ago. We moved to China. We spent there 4 months working on the soil prototypes. They are already working, and we are going to deploy the first pilot in southwest Spain this summer, in July. We are also looking for the pre-seed round. We are going to start very soon. So that's it. But the main point is that agriculture is a necessity, and we need to provide farmers with the technologies that they need and they can use. Thank you so much.
Thanks for a great pitch. Could you share a little bit about sort of what the impact of this solution would have on sort of the average small farmer, either in terms of crop yields or even better, the financial impact on their farm?
Yep. The impact depends a lot on the region and the crop. We have done some tests, some pilots in Spain in mangoes crops. Depending on the size, and it's very variable, but it's around 30 to 40% of water reduction in the A/B test compared to just irrigating by guess. At the end, by guess is no data-based, data-backed. So we can have a very big impact there.
One of the hard things with agriculture and technology adoption is the sort of basic familiarity with technological tools, interfaces, and things like that. What are the markets that you think are easier to enter in terms of technological fluency and ability to use the tool, and what are the markets that are later and harder?
So the big problem with agriculture and agtech solutions is that small and medium farms don't have any adoption rate at all. Why? Because they don't have the capability most of the times. Current solutions are just large farms. In terms of geographical regions, we need a very difficult mix to make this happen. We need some kind of infrastructure for communications. We need a minimum amount of financial resources. In our case, we're focusing on South of Europe, Spain, Italy, Portugal, especially high-value crops like fruits, olive crops, vineyards. That's like high-value crops. And also, especially here in America, California is very interesting for vineyards. They have the water problems, but also all the resources needed to deploy this technology. And in Mexico and Brazil, for mangoes and soybeans, they're also critical. At the end, it's the same mix, to have the infrastructure and the resources to make this work.
As you think about sort of the go-to-market, I know you're talking about that small to, this sort of piggybacking on Jason's point, that small to medium farm side. Have you looked also at like how you will go to that market and how you will start to acquire those? Because I mean, part of the reason is your point on just the capability to start to tap into that technology. But part of it is also just like almost like consumer education, right? And the ability to scale that customer adoption. I guess for the very first few sets of customers, like what do you think are the archetypes that you're looking at that would be most relevant and fastest to adopt this specific type of tech?
Yep. The go-to-market in this problem is crazy because small and medium farmers, they don't usually like to change the way that they have been doing this thing forever, for generations. For the first customers, the initial part, we are focusing especially in south of Spain, mangoes and avocados. They are very high-value crops. They have very important problems and challenges with water scarcity. They have restrictions of how much water they can use per square meter. So it's a very interesting market, and we also have the network there. We are farmers. We come from farmers, family of farmers, so we have the connections there.
Awesome. Thank you so much.
Thank you. And next up, please give a round of applause for our second pitch, Ferus Truck.
Thank you. 8,500. That's the number of housing units needed in where I'm currently based, New Haven, to meet the housing needs of our community by 2030. Now, I was on a call with the city of New Haven the other day, and do you know how many housing units they have planned by the city for this year? 0. Now, it's not just located in New Haven, it's everywhere. In Massachusetts right now, the projection is by 2035, we need 222,000 units of housing to meet the needs of the state. Now, these numbers are only growing larger and being exacerbated by the death spirals that were mentioned in the keynote, with climate change, resilience, and adaptation not really cutting it for the housing solutions that are currently in the market. That number right there, 39%, is the percent of greenhouse gas emissions that are from the built environment, whether it's from construction solutions or energy usage by buildings. And we really need a solution if we're going to tackle affordable housing that not only focuses on the housing shortage and the supply issue, but also controls for negative externalities to prevent death spirals like the one mentioned in the keynote. And that is why we need something that's better for the planet, faster for the planet, cheaper for the planet, and of course, more beautiful for the planet. And that's where Ferus Truck comes in. We're developing a suite of novel robotic construction technologies to deliver affordable, sustainable, and safe housing to communities in need. We're doing this through our patented translational slipform technology for our flagship construction 3D printing device. This is able to print load-bearing walls with electrical harnessing, plumbing, and insulation routed within the walls autonomously through the printer. What this also allows for is architectural flexibility and smooth wall creation, creating designs and structures that communities want to see in their community rather than something that looks more akin to a beehive, like the current construction 3D printers are delivering right now. We're excited to share that we've built out our team to 15 plus people. We've raised non-dilutive funding in the form of $70,000 based on awards and grants from the Yale ecosystem. And we've also filed 1 non-provisional patent and have 2 more in the works right now. If you're ready to join the housing revolution, we're excited to share our vision for a future that's greener, safer, and more sustainable for everybody. Thank you so much.
Can you say a little bit about the feedstock for the materials you're using from a climate perspective, carbon perspective, and also flammability perspective, given the recent wildfires?
Yeah, of course. That's a very important topic for us. That's a great question. So we're building the technology around utilization of sustainable material. So for our ordinary Portland cement, because this is a cementitious-based solution, we're actually using cement base that's based on calcium carbonate that's actually processed with electrochemistry rather than combustion. So Sublime Systems is one example of a partner that we've talked to that we're going to utilize for our ordinary Portland cement to bring it down to carbon neutral with a coupling of limestone calcine clay as other materials that are added on the aggregate side. And then accelerators that are also based on the Sublime Systems process, which are aluminum-based, that utilize more of the calcium carbonate rock to reduce waste and also reduce carbon emissions. So we're looking at a carbon neutral solution here for the cement base itself.
And the flammability safety component?
Yeah, so because we're essentially creating a fortress that's concrete, the flammability concerns are just not there like they would be for a traditional stick-built home.
Cool. So you mentioned sort of the context for this, which was obviously the housing problem, housing shortage. You know, I think as a lot of people see it, including me, the challenge is actually not really the build part, it's the permitting part. It's permitting zoning, it's the ability to actually get some of that stuff cited. The build is a relatively fast piece of that. given that context, is there a specific part of that market that you're going after first? Like whether obviously residential, commercial, small commercial, I don't know what subsegment you're going after, but I could see a lot of ways to skin that could be interesting.
Yeah, definitely. So we also understand that this is a complicated, nuanced problem, and it's more than just the construction portion. And so I'm actually a housing policy fellow for the Connecticut General Assembly to get that exposure on the regulatory side. And so we're going to start in New Haven for a couple pilot projects, which we've gotten letters of support from general contractors and the mayor of New Haven to really deliver within the frameworks that are offered there. So we'll be utilizing 9% LIHTC credits with real estate developers, which we have some letters of intent in the works. And then also utilizing some of the workarounds they have within the regulatory framework, such as 830G, which allows for changing zoning when you're delivering affordable housing units. And so one of the key issues that you have to tackle is NIMBYism when you're delivering housing. And so by utilizing 830G and showing how beautiful the structures can be, when you're really giving dignity to the people that are living within the houses, it actually reduces that NIMBYism and makes a product that somebody wants to actually live in.
Any code considerations that need to be thought about here? Is this totally compatible with all existing building codes? Or?
Of course, yeah. So that's one of the key aspects and differentiators of our product. We are building around meeting code to start, and so there's ASTM and ACI codes that are inherent with meeting building code in different jurisdictions, and so we'll be meeting those. Yeah. Thank you.
Thank you, Fedistruck. And last but not least, please give a round of applause for the last speech, Infinite Cooling.
Good afternoon. My name is Maher Damak, and I'm the co-founder and CEO of Infinite Cooling. Okay, I don't know what's happening with the slides, but basically we work on cooling towers, and these are the most common cooling system in industrial and commercial applications, and they're water-cooled systems, so they basically use water for cooling. They evaporate all that water, and you can often see these plumes rising out of cooling towers like these that look like smoke, but that's actually just all pure water. And just to give you an idea on the scale, over 50% of all industrial and commercial water consumption in the US is in these cooling towers. So they're huge. And there are a couple of problems with these. First, they all run very inefficiently. And one of the reasons is that there is no commercial solution that's able to do real-time optimization on these systems. So that's the first problem we're addressing. So we developed a suite of sensors along with algorithms that use physics and machine learning that are able to do real-time monitoring, predictive maintenance, and optimization. And the end result is a lot of energy savings. We've achieved up to 50% energy consumption reduction, increased cooling capacity. So we had customers generate 40% more cooling out of the same piece of equipment because they used it better, and less maintenance costs. And this is sold as a software product as a subscription. So that's the first problem. Then the second problem for those customers who have water scarcity is all that water in the plumes that's being evaporated. So we have a solution for that too. So this is a technology that we developed at MIT that is able to capture water that's coming out of these cooling towers and recycle it for use in cooling or other applications. And a couple of advantages there are the water is very pure, it's evaporated and then recondensed, so it's essentially distilled, so it's very high quality water. And the second thing is the elimination of those plumes, like you can see in that picture, which helps with some regulations and a variety of other issues. So these solutions are already implemented with a number of customers in a variety of sectors. So we have power generation, we're working on nuclear plants, gas, waste to energy, a variety of industrial processes and chemicals, food and beverage, chiller plants for buildings, like actually the chiller plant that cools the MIT campus uses our solution. And then there is carbon capture as well. So basically our main challenge what we're looking for right now is deploying this with more users. So if you have any sites that use cooling towers, happy to chat to see if we can help. Thank you.
Could you just talk about the market sort of take over the world strategy? Sort of like what are the initial these initial beachheads, and then where does it go from there?
Yeah, so we started, so our team is still pretty small. We're 15, mostly engineers. So we focus mostly on industrial companies right now that have a lot of sites. So to do a kind of a land and expand kind of strategy, where we start, like a lot of these industrial companies want to see a pilot anyway. So we do it on one site as a pilot, and then they like it, and then we can expand within their fleet. So those kind of, those can be highly lucrative enterprise contracts. And now, we are growing our sales team, and we're also starting to go after smaller players, which may have like one facility or a few facilities, but we can still help them. It just requires more, sales efforts and spreading the word and getting, because our main problem is that people don't know that these solutions exist, so they don't know that there are all these opportunities within their cooling towers. They assume that's like a given loss. So that's really what we're focused on.
Could you share a little bit about like the project economics of this in terms of, I assume there's some sort of electricity load that it induces, but also, whatever kind of return that gets you in water consumption savings?
Yeah, absolutely. So essentially, for our software product, the payback is typically less than 6 months. We start to put the sensors in, start getting feedback and implementing improvements, and very quickly everyone gets a lot of savings. So that's kind of a very quick payback, and we have a model where there is even no initial cost to the customer. For the water capture system, we don't have a generic model because it's highly dependent on the water economics is notoriously very kind of not uniform. So yeah, we have scenarios where it's a payback in 2 years. So we do an equipment sales model there. So we've had some of our customers are looking at a 2-year payback. In some others, it's probably longer, 4 or 5 years. It really depends on the economics.
Are there applications of this in the rapidly growing data center space?
Yeah, absolutely. Actually, not the small data centers, but all those hyperscale data centers that Google and Microsoft and all of those guys have, the majority of them use cooling towers for cooling. So people talk a lot about the chip cooling, like whether you use air cooling or water cooling on the chip level, but then actually all that heat that you extract from the servers needs to get out of the building, and that's what they use cooling towers for. So over 75% of them, and even the planned ones, will use cooling towers. There are some areas like Arizona and Nevada where there's really no water, so they have to use air cooling, but air cooling is a lot less efficient, so everyone wants to use these cooling towers. It's just that they're limited sometimes because of resource availability.
Are there, as you look at like the customer interest that you've seen so far, are there specific geographic segments that are most water scarce or under water pressure that you look at as the most attractive places to go, or is it pretty generic and the costs are equivalent everywhere?
No, we're working everywhere. Actually, we have customers on the East Coast, Midwest, Arizona, Canada, France. Like it's all geographies. It's really because, again, it's a local problem. So sometimes you may be in Massachusetts, but you may have very high costs of water and water treatment that justify this project, or you have a bunch of inefficiencies that kind of get triggered when it's very hot during the summer that make you lose production. So there are a lot of these case studies in all sorts of geographies.
Thank you.
Thank you.